The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Great, thanks, Tom. And I'd also like to thank Craig and everybody else for setting a great stage for me. So very quickly overview, talk real basically about beneficiation with just a tiny bit of philosophy. I'll introduce you to our technology. It's called STAR technology. And then I'd like to go over the case study where we're beneficiating from a pond. Quickly introduction to our company. We're a family-owned company based in Columbia, South Carolina, Lexington actually. We started business in 1976. We currently operate 4 thermal beneficiation technology plants, and we developed the STAR process as our own in-house process. And we are commercially reclaiming ash that's been previously disposed. That's a graph of our market area, obviously on the East Coast. We have 4 thermal plants that I mentioned. We also have 2 more that are in development right now under contract. So we also do non-beneficiated ash, byproduct ash, as well as beneficiated ash. So I can't believe I'm the first one to show the dictionary definition of beneficiation, but I guess I am. The treatment of raw material to improve chemical or physical properties. So why do we do it? Well, originally, a lot of utilities had this disposal problem. Some had very cheap disposal, some had very expensive disposal. So the utilities needed a way to recycle the material to avoid disposal. So recycling was a great way to do that, lowering their operating costs. Also, we have to, a lot of material doesn't meet specifications. We have to beneficiate it to meet specifications. Even some ash that meets specifications has a bad user experience. It needs to be treated or beneficiated some way to make it more user-friendly for our customers. And finally, as we've grown the market of fly ash and the acceptance in the marketplace has grown, the demand for the product, we need to find other sources for it. So the solution is beneficiation, and our particular mousetrap is called STAR. And it's an acronym that stands for Staged Turbulent Air Reactor. It's a thermal process, which we re-burn the ash. We finish the job that the power plant started. Our fuel source is the unburned carbon that's remaining in the ash. Exothermic, which means it gives off a lot of heat. It removes the carbon. We don't worry about LOI because we remove the carbon. We just basically take it out. We can remove all the carbon, all the organic carbon. We can even remove all the inorganic carbon, although there's no really reason to do it. Also remove the ammonia. In the old days, we used to have hydrocarbons left in the ash sometimes, and moisture, if there's any moisture available. And we have no solid waste stream from our process. So the product that comes out of the STAR process has what we call transparent air entraining characteristics, which means the dosage rate of a fly ash mix for air entraining is virtually the same as an all Portland. In some cases, it may even be a tiny bit less or a tiny bit more, but it's virtually transparent and it's very stable. It's very predictable, so there's not a lot of checking and adjusting air dosage rates. We also make the fly ash slightly more fine by going through this process, and we either maintain the strength the same or actually increase the strength a little bit as the fineness increases. This is the basic process flow diagram of the STAR process. The heart of the process is the reactor here, which is a violent air-filled combustion chamber with a very low detention time. Retention time is in seconds. The ash moves to our cooling loop. This is shell and tube cooling loop. And you see we have a lot of heat left over as we cool the ash stream down. Now the heat has a lot of value, especially the power plant. That's what a power plant does, is make hot water. So we have the ability to either give them the hot water back. We could also put our own steam turbine on that and generate electricity, sell it back to the grid, or use that heat for some other industrial process. Then the bag house is actually where we collect our product. That's the product collection. Remove the fly ash from the flue gas stream, collect our product, transport it for storage or distribution. Then the remaining flue gas stream then goes into our pollution controls, which is a small package wet scrubber. And then we release the remaining flue gas, which is mostly steam and a little bit of carbon dioxide. Our first STAR plant is called McMeekin. It came online in 2008. It's right outside of Lexington, South Carolina. So it's a smaller plant. It was our proof of concept plant. We've done a lot of different ashes through there, everywhere from 5% to 20% LOI. And we bring sources from all over the country and process them through there. And we're averaging below 1% LOI on our shipments. Our next plant was a much larger plant in Newburgh, Maryland. It's 100 million BTUs. This plant came online in 2012. We used 3 primary sources of feed ash for this. And once again, 5 to 15% LOI. And we always average under 1% LOI for our product. So fast forward a couple of years from 2012, a lot of this you've seen already. We've talked about natural gas already. There's lots of natural gas, low cost, especially in Maryland. You know, just north of us in Maryland is the largest natural gas field in the universe, the Marcellus Shale deposit. We've already talked a little bit about some of the new EPA regulations that have come online, the plants that have retired, the plants that have converted to dry scrubber, wet scrubber technology. Also, the new EPA ruling came out in 2015. So it was a very busy 3 or 4 years. And as a result, some markets where we used to see an occasional reduction in supply in the spring and the fall when generation is typically lower, now we go into crisis. We no longer have a shortage, now we have outage. And we see this a lot on the East Coast. You know, at one time last year, there was no coal being burned for generation east of the Appalachian Trail. Well, if you look at the country, most of the country is west of the Appalachian Trail, except for a few small markets like Boston, New York City, Philadelphia, Washington, D.C., Charlotte, Atlanta, Miami. Other than those, no problem. Few small markets. So how do you meet demand? That's our job as marketers. How do we meet demand? Well, we can move it further around the country. There's other ash in the country, which is can be a whole other session on itself. There's also imports. People are bringing ash in from other countries to meet market demand. We can also try, there's a lot of ash that has flue gas desulfurization products mixed in with it, gypsum and sulfur. We can try and beneficiate that. That's a real tough row to hoe. So there's another solution, which is reclaim the millions and millions and millions of tons that have been deposited over the years in landfills, and we call it surface impoundment, but we know them as ash ponds. Similar to the ash pond that broke in 2008 in Tennessee. We all know that story very well. Also, we all know that when you put millions and millions of tons in one spot, and they have trace amounts of red ping pong balls, you would put millions and millions of tons together, all of a sudden you have a substantial amount of bad actors like arsenic and mercury in one spot. So we have a potential liability in localized spots. And a lot of these happen to be on the banks of waterways. So I don't have to go through the benefits of using fly ash and concrete, and I don't have to go through the benefits of why we're recycling, but not only now, we go the next step past recycling, past diverting disposal, and that's actually reclaiming, remediating a potential environmental risk. So we can add that to the checklist of benefits of fly ash and concrete. There are a lot of challenges to it. I remember we had a 232 meeting here about 4 years ago in Washington, D.C., and we had very excited discussions about you can't take old ash that's been underwater, has all these problems. And there are challenges. Once again, the flue gas desulfurization. If we have that in there, that's kind of a non-starter. There's also a lot of water. When it's been in the pond for 15 years, you can imagine it's wet. Even dry ash, so-called dry ash, has been embanked at a 10-15% moisture content. So an ash does not give up its moisture easily. You cannot set it out and dry it. It has to be forced out of it using a lot of energy. Particle size distribution, fineness. You imagine ash flowing into a pond, settling here and there. And same with specific gravity. You're going to have similar ash in different locations of a pond or a fill site. A lot of people ask about weathering. You know, if you put fly ash underwater, is it going to devitrify? Is the calcium going to kick off that reaction and render it more crystalline and less gas. All the questions that are very good questions about whether you can use it. And finally, there's other stuff in those ponds and landfills besides ash. Dead deer carcasses and welding rods and all kinds of other stuff that ends up in the power plant. So, a couple of solutions. One is a great mine survey. Now we essentially have a mine like a sand pit or a rock quarry. It's a mine. We have a great mine survey and then a technology that can beneficiate a lot of those problems. And we've employed STAR to do that. So here's our case study now. It's called the Winyah Station. It's in Georgetown, South Carolina. If you're not familiar with South Carolina, it's about halfway between Myrtle Beach and Charleston on the coast. The plant is owned by Santee Cooper, is the name of the utility. They were faced by a lawsuit by a large nationwide environmental group just prior to the release of the final EPA ruling. They were being sued, and the claim was that they're polluting the groundwater. And the settlement that came out was, instead of taking up all this ash, permitting a new landfill somewhere else 20 miles inland, and moving it all at hundreds and hundreds of millions of dollars expense, and just keeping it in, moving the environmental risk from one spot to another, what about if they could remove that ash and beneficially use it? So the consent decree was to do exactly that. And we contracted with Santee Cooper to do that using our STAR technology. Now this is a plant we had been at before using a previous technology, so I'll show you some historical data where we did sell a lot of ash and processed a lot of ash from this plant in the past. This plant was built in 2014 and became commercially operational in 2015 in April. So the data I have on the landfill ash is since 2015, of April of 2015. So the plant there is designed for both the reclaimed ash from the old pond and from the plant. And I can say that we've gotten a lot more ash out of the pond than we have out of the plant. Generation has slowed down tremendously there. We have access to the on-site pond. We also have access to off-site ponds at other locations in South Carolina. So we have many, many years of storage available to us at this site. In this case, we use that waste heat I was talking about, that excess heat. We created a heat exchanger to dry the ash using that heat, and I'll show that in more detail. We have run this plant on 100% reclaimed ash for extended periods. We didn't exactly plan on that, but that's the reality of it, and I'll show data from that. So today we've processed 400,000 tons of fly ash total at the plant. It averages 60% being from the pond, 40% from the plant. But I can tell you that in the first quarter of this year, it's 98% from the pond and 2% from the plant. So we're running a lot of reclaimed ash now. And that's ash that's coming out of the ground, being beneficiated for concrete. So this is the same process flow diagram. We've added another green box here. This is our external heat exchanger. We take the excess heat from the cooler. We use that to create hot water to hot air. And then we bring our ponded ash in there, and then it enters the process flow just as before. So we can also do this by putting wet ash directly into the reactor. This particular site, all the site-specific worked out best to do a heat exchanger in this case. But we have tested this by just putting wet ash directly in the reactor, and it works very well also. So this is where it starts out on a pond. Obviously, it's been drained off for a couple of years. This is not a cosmic operation. That's an off-the-shelf excavator. See, he's constructed a bench of about 7 feet tall here, so he works across the face of the pond. This is a single deck. This is actually a multi-deck screen, but it only takes a single deck screen, very typical commercial application. We're using a 3/8 screen to sort out the welding rods and the deer carcasses here, and some of the organics. We bring it over to the plant using off-the-shelf equipment. In this case, it's on-site or off-site dump trucks. And then we enter the process. This is actually the exhaust heat exchanger. This metal box, it's about the size of a large shipping container to give you some scale. And you see the piping bringing the hot water in. Basically, we make hot air out of hot water with a fan, and we blow dry the ash. There's much more to it, but that's the limit of my knowledge of how it works inside. This is the other end of it. The silver silo there is a bag house. We don't want to discharge any of the fines. That's a future product for us. And then the little stack there is steam, where all that hot air and hot water is evaporated out of the top. And from there, it's dry ash, and it's transported over to the STAR plant. This is an overview of the entire STAR plant there at Winyah. This is the reactor here, this gray tower. It's about 7 stories tall. The cooling loop is right here, shell and tube cooling loop. And then this is the bag house. Once again, that's our pollution control equipment, but it's also our product. It's where we capture our product. So we're very highly interested in capturing every single particle we can out of that. And then from there, the bag house, it goes to storage dome and loadout silo and shipped off to customers. So at this point now, we'll talk a little bit about data. And what I'm going to do is contrast for you the pre-STAR condition using previous technology, but that was only using fresh ash from the plant, versus the STAR technology the last 24 months or so, using the STAR technology and a mixture of fresh ash and reclaimed ash. So I have 2 variables in here, and I apologize for that, but it's basically the best data that we have to show you. So and I won't go through every C618 item because we don't have all day. I just picked 4 to look at. And we're going to compare the averages from the C618's actual production data. So on the left, in the orange, it should be orange. It shows up kind of yellow here, but that's the prior technology, 53 tests, 53 months worth of reports. And the blue is current STAR. But anyways, this is loss on ignition. Our upper limit, 6%, even 12% if you need to. The previous technology, we averaged just over 2, and this was a fantastic ash. We had great market acceptance of this ash. We sold out every pound we ever made of that ash. Now we're averaging under 0.5 now. Standard, and I put these standard deviation and range as kind of a measure of the variability. So we've decreased variability, even though we're using reclaimed ash. So the next item is specific gravity. Interestingly enough, specific gravity has stayed almost identical, even though we're using a lot of material out of the pond. That's probably related to the coal source. Deviation is extremely low, range is slightly improved, and we have a uniformity requirement in C618, and we've improved that a little bit as well. Here's 28-day strength activity. If you're familiar with the test, they make mortar cubes out of all Portland cement and mortar cubes out of a 25% fly ash mixture, and then the difference is called strength activity. Our lower limit on that is 75%. In our previous technology in fresh ash, we were averaging just under 85%. And we've actually seen a very small decline here. We're down around 83, 82.5%. Well within spec, but we've improved on the variability and we've improved on the range. On strength. So if this was a marketing presentation, I'd stop right now and ask you all to sign up and buy 3 stars. But since this is a technical presentation, I'm going to show you the next slide, which is fineness. In this case, our fineness has increased. Our upper limit's 34, so we're well within that, but we have seen an increase in fineness. And that's mostly due to the fact that there's bottom ash commingled in with the fly ash. And our standard deviation, our range has increased, so we haven't improved that. And this is an area and our uniformity is not as good. So this is an area of improvement for us, but we are well within specification range. So I like to summarize, SAR is a self-sustaining thermal beneficiation technology, completely removes the carbon. We agree the LOI test is useless because if there's no carbon left, there's no worry about LOI. Same with the foam index. I don't care about foam index, there's no carbon. So. And it has excellent air and training characteristics. Our customers report very stable dosage rates. They don't have to spend a lot of QC effort worrying about air and training. We have successfully and commercially beneficiated ash for over 2 years now, South Carolina. We have great market acceptance of this. We've shipped this ash as far north as Delaware and into Florida if we had to meet projects where there was physically no other ash available. And at the same time, we're remediating environmental risk. So our technology is one of the many you've seen today. Not every technology works perfect for every solution, but my personal philosophy is the power of the innovation of the people in our industry. It's a robust industry, and we all have innovative technologies to meet demands, and we're going to have flash for lots of years to come. So thank you.